Hello, everyone. Let's get started. I would like to welcome everyone to our architect's presentation, High-Rise Affordable Housing, organized by New York Pass House and AI New York. I would like to thank AI New York for being a partner in this event, and a special thanks to Dutner Architects for their support of New York Pass House throughout the years.
They all built upon the prior project's experience. So we've been able to develop a deep bench of people that have a great deal of knowledge, experience, and enthusiasm about passive house and sustainable design. So each one of these projects is also in construction. Some of them are just getting out of the ground. Some of them have been topped out and are getting very close to being completed. So there's a great deal of lessons that I think we can learn from each of these. So this is what we're going to share with you today. So I'm not going to read off every one of these learning topics, but we think that there is we know that there is a great deal of synergy between passive house and multifamily housing. As many of us on the call probably know, that one of the things that passive house really relies on is internal heat gains. And a typology such as multifamily housing, especially in a dense urban environment, the internal heat gains that you can take advantage of in a multifamily building are they're inherent in that building type. So there is a great synergy between those two, between passive house and multifamily. So we've also, on a couple of our projects, we've been able to work very closely with contractors and come up with details that, were not just designed by an architect working in CAD or Revit, not just a therm modeler trying to figure out the right way to reduce the thermal bridging and heat transmission, but also working with the people who are actually going to be putting these things together in the field, figuring out the way to build them in the most efficient way and keep detailing in a way that it's constructible and efficient and really facilitates adapting passive house detailing into affordable housing projects, which have a really, not shoestring budget, but we're always thinking about cost. And so we've been able to develop these details in a comprehensive way that really keep them efficient and buildable for a passive house project. We also, since all these projects are in construction, as I'm sure many or most of you know, that construction will throw you curveballs. And on passive house projects, there needs to be special focus to make sure that you don't compromise things like your air barrier continuity, your insulation thickness, and keep minimizing those thermal bridges. Another thing that you're going to see today is specific challenges that are related to mixed-use buildings. Sometimes they're challenges, sometimes they're opportunities, but there are things that we're going to show you today that allow you to approach those conditions in a way that really makes sense for passive house. So as Caleb said, most of our work is in New York City. I'm sure you know many of our projects, whether you know it or not. But we're grounded in civic architecture. We do libraries, we do schools, we do subway stations, we do medical facilities, and a great part of our practice is affordable housing. Some of you may know this project. This is Via Verde. It was completed about 8 years ago. It was something that came about as a competition that was sponsored by the city. And it really is a great example of integrating sustainable design, whether it's the integrated PVs, the rooftop gardening, but it also is a great community that has been created here with some of the amenities and the number of people and the income mix. So it's a great project and a real exemplar of sustainable design. I think one of the things that we have discovered recently is that we can do a lot better. You can see Via Verde on this predictive EUI chart did pretty well. You considering when it was designed and in relation to other buildings, especially when you look at the national averages. But you also start to see how passive house can really make a deep, meaningful difference in your building's energy consumption. Now, I think we all know that sustainable design is more than just energy consumption. We have a group in our office, the Sustainable Practice Group, and they focus on more than just energy. They really look at a comprehensive look at all the factors that go into creating a healthy, sustainable urban environment. And you're going to meet some of those people today. So I'm proud to be working with all of those people. And here are some of those people. So each one of them is going to walk you through these projects. They have helpfully, as a visual cue, put in their backgrounds, renderings for each one of the projects, so you can really tell who's going to talk about what. So with that, I'm going to hand it off to Heather.
Hi, I'm Heather McKinstry, and this is 425 Grand Concourse. It's a 26-story tower with 207 developers are Trinity Financial and MBD Community Housing. The GC is Monadnock. The Passive House consultant is Stephen Winter Associates, and the MEP engineer is Dagger. So the structure of this building is cast in place concrete with a CMU backup wall. For the tower, the facade is metal panel, and we have brick at the 2-story podium. Along with the, really most important passive house design strategies, we also implemented other passive design strategies like sunshades at south-facing windows and green roofs at the 3rd and 25th floor roof terraces. And those roof terraces are also residential tenant amenities. The podium of the building includes a variety of uses, including a dental and ambulatory care clinic, a grocery store, a comfort station for the park, which is just to the north of our site, and the entire 2nd floor of the building is space for the CUNY Hostos campus. So as you can see here, the building is under construction. This picture is a couple of weeks old, so they've pretty much completed the structure of the foundation and cellar, and they're working on the 1st floor slab now. Construction is expected to be completed in August of 2022. The complexity of determining the locations of the air barrier and the passive house envelope and the decision to use centralized ERVs is what we'll talk about further today. So we contemplated 3 approaches to the ERV layouts. On the bottom left here, you can see our typical tower floor plate with a semi-centralized ERV that serves the entire floor. In this configuration, we lose a bedroom on each floor, and with affordable housing, your bedroom count is really important, so this was not really acceptable programmatically. On the top left is a typical apartment layout with its own ERV. While this individualized approach allowed for a high level of responsiveness to the conditions in each apartment, having 277 ERVs to maintain, along with access issues when servicing units within apartments, and the addition of 554 penetrations, 2 for each ERV, through the exterior wall made this approach impractical. On the right, you can see diagrams of the centralized approach that we ended up going with. Because of the height of this building, we ended up with two zones. There's a low zone, which is served by ERVs on the 3rd floor roof terrace, and an upper zone, which is served by ERVs on the tower roof. These larger units are pretty efficient and they're easy to maintain, they're easily accessible, and the vertical shafts were fairly easy to configure into the apartment layouts without taking up a whole lot of extra space. And as I just mentioned earlier, one of the challenges of designing a multifamily mixed-use passive house building is determining the location of the air barrier and a passive house envelope, and what goes within that envelope and what stays outside of it. So as with most, if not all, passive house projects, the team put together an air barrier drawing set, which helped clarify which areas are outside of the passive house air barrier. the decision was made that for the retail space, which is shown here in the plan as 4 smaller retail spaces, but is now planned as 1 large grocery store, that would not be included in the Passive House envelope, so that the future tenants would have more flexibility when installing their own kind of mechanical equipment and how they were going to function within that space. But that space is within our Passive House air barrier. On page right of the plan, which is north, you can see that there's a small area that's outside of the air barrier and also outside of the Passive House, and those are that's the comfort station for the park directly to the north of our site. So that's 2 bathrooms and a storage closet, like an M&O closet for the Parks Department. At the top of the plan, which is west on the site, is the loading dock for the retail space, as well as the non-residential trash storage room, which has the generator mezzanine directly above it. So those spaces required large openings for ventilation, as well as a large door for the loading dock. And the decision was made that they will be excluded from both the Passive House envelope and the air barrier for those reasons. Since we were kind of carving out these spaces to be excluded from the air barrier and the Passive House envelope, we had to really look in detail and in section at what that meant for the continuity of the air barrier. So in plan, we used double CMU walls to enclose the air barrier and insulation and provide a really durable finish, as those spaces are kind of back of house and really need to be able to take some, they just need to be pretty durable. In section, we had to think about how we were going to bring insulation onto, an interior ceiling to make sure that in this section, you can see the CUNY space is sitting above that generator mezzanine. So making sure that we are meeting the performance requirements of all the spaces within the envelope while having some of these spaces that are excluded from the envelope. So we detailed kind of each of these corner conditions. You can see that they're called out in the plan. And it became really clear when especially when we were working in section and detail, that having a cast in place structure was really helpful in maintaining that air barrier in spaces that were stacked on top of each other when one space was excluded and another one was included.
Great, thanks Heather. I'm Rebecca. I'm going to talk about the next project, which is the 1230 Metcalf project. So you can see it here in the rendering. The team for this project was the client JV Associates, the contractor Monadnock Construction, our Passive House consultant was Bright Power, and the MEP consultant was Skyline Engineers. This is located in the Soundview neighborhood in the Bronx. It's immediately adjacent to the number 6 elevated train, which you can see in the rendering running there to the south of the site. The Bronx River Parkway is immediately to the left of this rendering, to the west. And this is a 12-story building with partial cellar, and it houses 249 apartments. So this ground floor of this building has a community facility, has retail spaces, and a residential lobby that serves those 249 units on floors 2 through 12. This is a different type of construction. So this is precast plank floors with metal panel and brick veneer on CMU backup, so provided a different challenge for us. And this is also in construction. This is actually pretty far along. It's about 70% of the way done. We're expecting completion in April of 2021. And for this project, we're going to focus on the window detailing and metal panel detailing. This was a major feature for the design because we knew that our windows were going to need to perform very high acoustically because of our adjacencies to the train. So here is a very early mock-up that we did during construction. Because this is an affordable housing project, it was important for us to find cost-effective materials and straightforward techniques as we sorted out our details. So we worked with a contractor during design to work on those details. And you can see this mock-up that we did early in construction allowed us to really sort out how the details that we had developed were going to work in the field. So the head sill, jamb, and metal panel where they meet that very deeply recessed window became a big design challenge and a big opportunity for us. The plan, you can see that the face of our window, which is to the left in the plan, is aligned roughly with the exterior face of the CMU. And that air barrier that Heather was talking about for our building is running right along that same line at the exterior of that CMU wall. And so that gap between the CMU and the window was going to be that very critical location for sealing and making sure that continuity was there for us. Beyond that, we also have this very deep cavity wall. So there's 4 inches of insulation. There's a gap for the air gap, and then there's our brick. And so we're looking at between 7 and 8 inches that we want to close. And we didn't want to do that with a brick return because we were concerned about thermal bridging. And so instead, and in coordination with our design, we looked at closing this with a metal panel closure piece, which is the yellow that you see in plan at the jamb. And that is attached to this closure anchor that you see in blue. That sits on a thermal shim that breaks that thermal connection. And so you get that nice thermally broken connection at your jamb. At the window head, which you can see in this mock-up, there's a very deep steel ledger that will be painted yellow. So the design concept was really to wrap multiple windows in this frame. And so the ledger is going to serve that purpose. If you go to the next slide, John.
Actually, I'm gonna
Sure.
some privilege here. There's some good questions in the chat.
Sure.
Some were on 425 Grand Concourse. I think we'll have to come back to those. There's a question about acoustics. You want to talk a little bit about the acoustics here? The question is really related to I think it's geared towards how the residents have given us feedback. We don't have feedback yet, but if you could talk about the acoustical part of the project, that would be good.
Yeah, absolutely. So these are UPVC windows. This is an OITC 35 window. It's a double pane glass. The glass itself is about 1 3/8 inches total. The frame's about 3 1/4, and that gives us that OITC 35 that we need on that train side. So that was something, like I mentioned, we knew was going to be important and get us part of the way there for Passive House for the acoustics. The wall itself also has very high acoustic demands. The wall is estimated at an OITC 46 for both the metal panel locations and for the brick locations. So those were things that we had to take into consideration. And this seal, this continuous seal that's happening at the window is part of that performance.
Okay. And
Yep.
there was another question about how are these projects affordable, and someone answered about there being lots of subsidy, and I'll modify that response that someone offered slightly, because this project has an environmental condition that causes it to, as Rebecca's described, have a premium window and atypical heating and cooling system for an affordable housing project. So because of these site-specific conditions, it was halfway towards Passive House already. So it made a lot of sense to make that next step and really then be able to reap all the benefits from it. So there's a lot of questions. I wish we could answer them all. Maybe we'll come back to them at the end.
If we look then at the header condition, so you can see this steel ledger on the left in the large photo that occurs over the window opening. And so that's on thermal shims, the same in a similar fashion to the anchors at the jambs. So we have very deep ledgers over the window. And like I mentioned, that's to close that gap. You can see in the top right detail that we're using that ledger both to hold the brick above and to close off the cavity wall and complete that frame that we're using visually on the exterior. Beyond that, there was a challenge. So you can see in the photos that we switch at the masonry openings from this very deep ledger to a different condition at the piers. And that was really due to the bearing capacity of those ledgers. Because they're very deep, the structural engineer was really okay with only a certain amount of brick being held up by that ledger. So at the window openings, that's fine because we have stacked windows. There's only about 4 feet of brick above that. But when we get over to the piers, it's almost 20 feet before you get to the next control joint. So we needed a more traditional method at those locations. So you can see here we're switching at the piers to this ferrofast clip system, which is something we use often on our very deep cavities. It allows that insulation to pass in between the clips, which improves our thermal performance. It also cuts down on cost because these ledgers are quite expensive. And so that was a solution that we employed. In the top middle picture, you can see how that relates to then the air barrier and flashing that eventually is applied. So in the image, you can see at the top, the shiny black material is the air barrier, which is rolled on to the exterior of the CMU. The self-adhered membrane is the blue. And then the through-wall flashing is the yellow that goes from the CMU and then out to that drip edge. And so because there were these two systems, those get sealed separately. And so you can see one of them has been done here and the other is about to be done. So like I mentioned before, the connection at the window became this very critical detail for both acoustics and for the air seal. So here are some progress photos of that window going in. You can see top left, the sill with that air barrier on the inside of that CMU opening. In the top middle, the window going in, the anchor straps, and then the edges of that air barrier sealed. And then at the next photo to the top right, we see that 3/4 inch gap that we had all the way around the window getting closed. So that sealant goes in between and around all of those anchors so that we get this very tight seal in our finished product. And with that, I'm going to hand it over to David to talk to us about Chestnut Commons.
So Chestnut Commons is the third passive house project we're going to be talking about today. This is a rendering of it that you see. The client is a sort of a tripartite of Mutual Housing Association of New York, the local development partner is the Cypress Hills Local Development Corporation, and Urban Builders Collaborative. The general contractor is Latier Construction. Our passive house consultant was Bright Power, and our MEP engineer is Skyline Engineering. The location is in East New York. The project's under construction, and we hope to finish it by June of 2022. The specific location in East New York is along Atlantic Avenue. It's parallel to a buried Long Island Railroad line. It's in the Cypress Hills neighborhood. If anyone takes the subway out there, it's the Crescent Avenue stop on the J or the Z. The neighborhood is part of the East New York rezoning district, which encouraged high density and increased affordability. The project, like some of the others that we're presenting today, is mixed use. We have residential multifamily on floors 2 to 14. We have a community center located at the cellar and the first floor, which includes a multi-purpose space for recreation or performances, offices, a maker's lab, and actually a culinary training kitchen. And then plus the third use is some local retail at the ground floor at each of the building corners. It's slightly over 300,000 square feet, 14 stories, and this has 275 apartments. Sort of getting into the passive house capacity of this project. It's going to be certified under the FIAS 2015 certification. There's a cast-in-place concrete superstructure for our exterior walls. Rather than block, we have metal stud veneer, which we're installing 6-inch mineral wool in the cavity. Then we're cladding it with an exterior sheathing. Over that, we're cladding it with the air vapor barrier, and over that, we have 4 inches of rigid insulation, which is going to be the thermal barrier for either EFIS or the face brick, depending on the wood. orientation. And picking up on the earlier question about sound attenuation, we're going to be talking a little bit about how the site requirements can leverage us as designers to use Passive House. For example, the environmental impact statement required a sound attenuation of at least 35 decibels for windows and facade, which is the metric that Rebecca, that you mentioned. And so here we're specifying a Passive House certified window, and it's an opportunity to meet these attenuation requirements while providing improved thermal performance of the envelope. Another site restriction was we're redeveloping a brownfield, so we're having a sub-slab depressurization system and a soil vapor barrier. So this gives us an opportunity to strengthen the air and vapor tight foundation of the enclosure, which is obviously a tenet of Passive House. The other story behind this building is our clients' goals of deep affordability, coupled with lowered operating and utility costs for the tenants and the ownership, along with the community services. So, but the client was also wanting to learn from severe weather events like Superstorm Sandy and develop a building of resiliency after seeing the vulnerability of those weather events. So Passive House became a good technical strategy to address some of these concerns. The high performance envelope allows the residents to shelter in place and occupy their apartments with improved indoor comfort and health in the event of power outages. The project is also unique because it has a 100 kilowatt gas generator, a combined 35 kilowatt combined heat and power system, and a 90 kilowatt photovoltaic system with battery storage. But here, it's interesting because our high-rise occupancy required by New York City building code requires a generator. So we were able to leverage that requirement of the generator with the plan for the combined heat and power to improve resiliency. Also, we have two outdoor terraces, one at the second floor and one at the main roof, which is also applicable to occupant safety in the COVID-19 era. So this slide talks a little bit about what we've learned from moving from the details of Passive House to construction, and it's not so easy. There are many general contractors out there that are gaining expertise in Passive House, and that's to be applauded. But there are also contractors that are working on projects, their first Passive House project like ours, and there is a learning curve to build a literacy and familiarity with the principles of Passive House as they relate to construction and the design and construction industry. We need to disseminate these lessons learned on sequencing, material installation, craftsmanship, and testing, and it all can be accomplished. So this particular slide was a field report that we prepared after looking at the continuous sub-slab insulation. We have 2 inches of XPS, and because of the design of the mat slab, we have differing heights or profiles of the mat slab. So we're going from a high point to a low point, and the area circled is that transition where we sort of go into a valley. And you know, the foundation contractor, we had a difficult time sort of fitting, cutting, wedging pieces in, and you know, that's not it's really not permitted to have a thermal break like that. So you know, we pointed out that at this stage before the vapor barrier was on, and they could address it. The next sort of challenge is the transition of the different vapor barriers. We have a vapor barrier of a 20 mil Stego wrap. That's the yellow polyethylene sheet. And then it transitions to a GRACE pre-proof blindside foundation waterproofing. So we have to work with the contractor, the manufacturers, and the installer to make these transitions both high performance and for warranty. So this is really just a matter of quality control, and it's simple stuff, but the more we do it, the better we'll get at it. Another sort of aspect of construction quality control that we realized was with the support of excavation, where as the contractor installs piles around the site to provide the depth for the foundation, they install lagging heavy wooden boards in between the vertical steel piles to support the earth. And in this particular picture, in the upper right-hand corner, we have a little clip from our supportive excavation drawing. And if you notice, there's a little jog or bump out at Dinsmore Place. We call that the dormer. And the foundation contractor installed the lagging and the piles sort of in a triangular shape. But our building foundation has sharp corners, and we work with the contractor to recognize this detail. And in the lower right-hand corner, you can see how there's a void or a sort of furred out space where the foundation contractor had to sort of shim out and fur out that void between the angled lagging and our the profile of our foundation. And here it came out well. And you know, it's a little extra work, but it allows us to install a continuous foundation installation. Here's 2 inches of XPS plus the drainage board and the water vapor barrier inside of the foundation. And the photo on the left, lower left, shows sort of a view towards Dinsmore. And if you look in the distance, you see the beginning of the vertical rebar coming up and the angled lagging behind that. So it's, you know, our building has a simple geometry, but still it requires care to get these passive house details right. So this picture is talking about some of that quality control with the lagging. So starting with the upper left, that's a clip of a plan section detail that we have in our drawings that shows the supportive excavation and the foundation assembly. We have starting from, I guess, right to left, we have the earth, we have the lagging, the lagging, which is held up by in this case, an H pile. And then we have a drainage board, then we have our insulation, and then in the purple is the continuous pre-proof. And it intersects with the H pile, or in this photograph, the round caissons, where we have to maintain that waterproofing continuity. So it's challenging, and the worker on the right is installing that pre-proof water barrier against the caissons. He's installing it with tape at the joints, and then after the tape, he's going to put a mastic on it to keep that continuity. So it's fussy, but it can be done in a deep excavation like this. This last slide is about unforeseen conditions and remedial work. So I guess starting with the story of the picture on the upper right, we knew from the survey that there was a 20-inch DEP water main below the sidewalk on Atlantic. And that is shown in the circle, the 20-inch circle on the left. What we didn't know was that there was a buried foundation wall that was apparently helping support this water main, or perhaps was part of a former building, and it happened to be smack in the middle of our property line, which is shown in that vertical dotted line. So our contract foundation detail was bringing our foundation like dead on to the property line. So in the midst of a foundation, we all had to hustle and recognize the location of this foundation wall. There was a decision not to disturb it tremendously to protect the water main. So we moved our foundation inboard, but we had to be cognizant of the gap for continuous insulation and air and vapor barrier. And we transitioned from the foundation to a slightly cantilevered slab to support the rest of the facade. So it was tricky to deal with that condition. Similarly, when you're working on a zero lot line, we have a project that abuts a school under construction, and the photograph on the left is our brick shelf. And the remnants of an H pile that was torched off and lowered to allow finished grade of the adjacent property. So we're going to work with a contractor to repair that pre-proof. Then we're going to, and make it a watertight continuity for the brick shelf, then install the insulation, then the drainage board to allow our finished facade. So I guess the lesson here is, stuff happens in construction, and with with folks paying attention to the performance of passive house details, working collaboratively, the performance can be maintained.
Thanks, David. This is Shefali. I'm going to talk about Vital Brookdale, which is a project in East New York, Brooklyn. It was RFP'd as part of one of the state's vital sites that they started releasing the RFPs for in 2018. The client here is a for-profit partnership group called Pantheon Partners. The GC is Monadnock. The passive house consultant is Bright Power, and the MEP consultant is Skyline. Luckily for us, it's people that we've worked with on passive house projects in our office before, so there wasn't a lot of sort of reinventing the wheel, if you will. The building is essentially 2 wings connected by a single-story portion. It's 7 stories on the wing that you see on the right and 6 stories on the wing that you see on the left. It's 160 units and 185,000 square feet. So like many of the projects that you've heard before, it is a mixed-use program with the first floor primarily a mix of community facility spaces, including an outpatient medical office, a food program space, and nonprofit office spaces. The construction is block and plank, CMU with brick veneer, very typical for affordable housing, and also things that we've already done in the office. So in many ways, it was a lot of sort of low-hanging fruit. We had the details, we knew how to make it work, and we were able to benefiting from the experience of those who came before us. It's going to be certified under FIAS 2015. It would sort of snuck it in right before the change from 2015 to 2018. And it's also going for a NYSERDA NCP Tier 3 and Enterprise Green Communities. As I said, there wasn't a lot of new things here that we grappled with. The issue on this project, as you can see from this rendering, is that it's very long with many exposed facades and a lot of glazing. And so the things that we had to really deal with here was our surface area to volume ratio and the impact of our glazing area. You know, as architects, we want to make sure that we're designing a project that looks good, that works well for the tenants of the building, especially in a multifamily affordable residential project. But we had we had a lot of back and forth with Bright Power. As they were running their model, they said, you have too much glazing. You have to reduce the amount of glazing. And we're like, okay, but we also have to provide light and air for the tenants that are living in the building. And we started coming up against caps for insulation that we could provide in the mass area. So we have R70 at the roof. These walls, I know someone asked in the questions, these walls have a insulation, the R value of about 26.5. We struggled with adding more insulation at the inside face. We sort of capped what we could provide at the exterior face. And the issue really was in the glazing. When the RFP was submitted, there was mention of passive house elements, but it wasn't explicitly stated that it would go for passive house certification, so that the budget that went in with the submission was a more standard affordable housing budget. So we had to figure out a way to meet passive house requirements to make sure that we were meeting the cooling load requirements while not going to triple pane glazing, which is something that I think Bright Power really wanted us to look into, and staying within the budget that was agreed upon with the state at the onset of the project. So we really had to look at different glazing options and increasing the U value and the solar heat gain coefficient and finding that really fine balance between all of these different elements. And also part of that was convincing this for-profit client group that often makes decisions based on budget and less decision making is a little different from some of our nonprofit clients that make mission-based decisions, that this was important and it was a good idea and it was worth putting the money into expensive glazing. And you know, I think we were fairly successful in that. We started construction just about 3 months ago, so we don't really have a lot of fun, interesting construction photos to share. We're hoping to be complete sometimes in 2022, but that was really the thing here that we struggled with the most, is that in spite of the density, because of how much surface area we had, the density wasn't really helping us. And in some ways it was sort of hurting us because we needed windows for living rooms and bedrooms.
I'm hoping that I'm not going to get interrupted by a fire alarm test. I don't know if I had to mute myself briefly, but my colleagues know what I'm talking about. So to wrap this up and reiterate some of the kind of the lessons that we really want you to take away from this, Passive House is not rocket science. It is certainly taking a typology that we all know, or not all of us, but many of us know, affordable housing or housing in general, and amping it up a bit. But it's not rocket science. We're using standard materials, we're using standard systems, and we're just putting them together with a little bit more care. I think I speak for my colleagues when I say that once you've gone passive, it's hard to go back. It's hard to, once you've put in that care and that thoughtfulness about how some of these details can work and can be improved, to then change your mindset and go back to the way that we used to do things is really hard. But it can be done. There is a premium, but I think one of the things that's we've seen is that there are sites that, as I said earlier, that can really, that you're halfway there because of the environmental conditions. So multifamily and passive house are a great fit. The internal heat gains that you get from occupants, from appliances, from lighting, they really change the energy profile of the building. But you do need to have that special care about the air barrier, about the systems. Everything's got to be sized right. If you pull out one piece of it, if you have a team member that says, you know what, why don't we just relax a little bit on the mechanical loads and maybe change the window performance, the whole thing kind of unspins itself, because if you change the window performance, you might get condensation on the windows that could lead to mold growth. So the whole thing really has to work together. I do think that, all of us who are working on affordable housing and thoughtful about the environments that we're creating, we're probably all thinking about COVID and how that may impact our buildings in the future. I do think that Passive House has some real advantages. The superior indoor air quality that you get from these projects with the filtered air and the heat recovery that comes from that, there is a real advantage. And I think also being able to allow people to shelter in place more easily. Hank Keating, one of our clients on 425 Grand Concourse.
And some questions. There are a lot of questions in the chat box. So if the data team could pick some of those questions. I saw a lot of questions regarding the double pane and triple pane window kind of scenario. Just want to make clear that, of course, the PHI standard, you can do double pane windows. You just have to show that thermal comfort is guaranteed and your condensation risk is minimized. Probably could you address why you chose the double pane and how you address kind of condensation risk and thermal comfort?
Yeah, we're using the double pane at our 1230 Metcalf project, and Sahar actually responded to one of the questions really well in the chat. She was one of the team members that worked on the design drawings and is very close to this project. And it is actually, there is a second pane. There's a laminated piece of glass. So you do have three pieces of window, even though it's a double, or I'm sorry, three pieces of glass, even though it is technically a double pane window. And the big advantages were cost. We used UPVC to achieve the performance that we needed, but also keeping the frame depth down as well was something that we were looking at, and that helped with cost as well, specifically.
There's a couple questions about how is air conditioning done, and are we seeing VRF costs come down? I do think that, as contractors get more familiar with systems that they were not familiar with a couple of years ago, we are seeing costs come down. The air conditioning is being handled, air conditioning and heating is being handled through VRF systems, variable refrigerant flow systems.
I can also speak a little to that. I mean, you know, I think all of our projects have that split system VRF. It provides heating and cooling. I know with affordable housing, there's always that question of, you know, who pays for heating and how do you handle that with the affordable housing structure that we follow in New York City, where the tenant should not have to pay for heating. And often what we do is we put a meter on the refrigerant line so that they're paying for the cooling, running the refrigerant line during cooling season, which I think really helps. We do, David mentioned this in the chat, we do have gas-fired hot water heaters. On Vital Brookdale, we designed the project while there was this issue with the pipeline and whether or not we would actually have gas. And so we did a study on going to dual fuel and struggled mightily with the idea of bringing in oil into a passive house project that is designed and being built in 2020. But we did we were concerned about the ability to meet passive house certification or our markers and our thresholds for passive house certification going to dual fuel. But we found that we were able to do that by making concessions in other places. And then when we went back to gas, we just kept the concessions and just ended up with a better building, which was kind of nice.
There's another good question about embodied carbon on these projects. And I do have to say that I think that's one of the next areas that as an industry and designers, we do need to focus on. I think, you know, all of the materials that we're using here are carbon intensive. You know, New York City has not, I don't think we can do mass timber buildings at this scale. But I do think that is kind of the next thing that as professionals we should all be looking at is how do we reduce that. I know there are ways to, you know, source steel that uses more renewable power to run those arc furnaces. But I think as an industry and as a market, the marketplace is just not there yet.
John, I just want to add one thing to what you're saying and address Carmel's question. So admittedly, the goal of the projects you've seen are to reduce operating costs and energy use once the building is built. But exactly as John said, the next hurdle we're going to be doing is looking at embodied carbon, looking at the CO2 output associated with sourcing materials, and the North American Passive House Network conference has had many excellent sessions on software like Tally and other softwares, and our office is planning to begin to look at the analysis, the life cycle analysis essentially of a buildings from its birth to its death, and we will be studying like other professionals, you know, the energy use for extraction, production, versus the energy saved during operations, and it's a critical balance.
I do see a question from that asked about the ventilation strategies. On 425 Grand Concourse, the way Heather described the process that we went through on that project, we learned some very hard lessons about high-rise and mid-rise that from an operations perspective, from an air barrier perspective, that doing a unitized ventilation system is really challenging. Now, that's not to say that, you know, unitized ventilation can never be done in a passive house project, but I think when we're talking about these high-rise buildings, the centralized system just makes so much more sense. Yeah, I've had somebody ask in one of these sessions, does that mean that there's no more unitized ventilation for passive house projects? No, that's not the case. I'd like to make another point here about all of these projects. They each have different superstructures. They have different envelope designs. They have different programs, different ways to utilize on-site renewable power. So the subtle message here is that passive house is not a limitation on your design options. It does make you focus more on some of the technical aspects, but we have, through a lot of hard work, figured out a way to make it so that you don't need like a 2-foot thick wall. You don't need a hay bale envelope. We're using typical construction techniques that are not a limitation. So anybody that says, oh, you can't do passive house because it really limits your design opportunities, that's not the case. It really, that is not a factual statement. So we're very proud of what we're doing, and we're really proud to be working with a great group of clients to be able to deliver these projects.
I think Caleb had a question that has come up a couple of times. I think I saw it earlier on about the ventilation and if all the projects took the same strategy and how many shafts per floor, 1 shaft per 2 apartments, et cetera, et cetera. I think that would be a good one to end on. So we, on Vital Brookdale, we have, everything is vertically exhausted. We have ERVs on all of our roofs because we have roofs at the 4th floor, 6th floor, and 7th floor, depending on the building. And we have essentially, if we can share between 2 apartments, we have 4 shafts, or 3, at least 3 shafts, right? So we have 1 for kitchen exhaust, 1 for bathroom exhaust, because they can't be combined up until they hit the unit on the roof. And then we have 1 for supply. And then because these are for Vital Brookdale and 1230 Metcalf, because they're block and plank, and we have shear walls and all these other intermediate walls, that means that we can't always do back-to-back. Sometimes we just have 3 shafts per apartment, which is also, you know, a lot of fun. So that's definitely something that you have to allow for with, when you're laying out the units. I think many of us are used to doing affordable housing layouts, right? I mean, up until HPD changed their guidelines last year or the year before, but it's kind of like puzzle pieces that you fit together. You have this idea of how these units should go, and you just do them, and you lay out, and you do these preliminary schematic layouts saying these are how many units you can get, and then you have to start carving away for all of these shafts. And I think that that was something that we, for Vital Brookdale especially, grappled with, because it was also the client's first passive house project. And so they were looking at numbers, and they're like, this is 25 to 30 square feet more than what we typically see. And we had to explain to them that you had to keep the space for all the shafts and all of that ductwork that's associated with doing a passive house project, and also thicker demising walls between a living room and a bedroom, so that the refrigerant piping could run to the VRF unit. So there's all these different things that you have to start accounting for, which it definitely impacts the way that we typically lay out units.
I'll say that's really similar on 1230 Metcalf. We're using the same sort of strategy where we do back-to-back units, sharing a group of shafts. And in just for like quick comparison, where Heather was talking about 2 big ERV units, we have, I think, 14 at Metcalf. So there's 25 units on a floor, and then there's a shaft that's serving those units all the way up, just to give you a frame of reference for how that might change your ERV count. And that's something to look at kind of early with your MEP team to decide what's going to be the best fit for the project, depending on the typology, the site, and the needs in the project.
Well, thank you so much to the entire team for presenting all the buildings and share with us your experience and the struggles sometimes, but also the successes. I think that's important to figure out how we do high performance buildings. We'll make that recording available on our website, so please join us at nypassivhouse.org. Also consider to become a member and support our efforts like today. And so special thanks to Dattner Architects. I hope we will see many, many more passive house projects. Thanks, guys.